11.2 Types of Chemical Reactions.
Hi, I'm Kathleen O'Neill, and my topic is combination reactions. A combination reaction is a chemical change in which two or more substances react to form a single new substance. An example of this is 2Mg plus O2 yields 2MgO. When you combine a nonmetal with another nonmetal, you will get a binary ionic compound. When you combine a nonmetal with another nonmetal, or a nonmetal with a transition metal, it is possible to get more than one product.
Some chemical reactions are the opposite of combination reactions. These kinds of reactions are classified as decomposition reactions. When mercury 2 oxide is heated, it decomposes or breaks down into two simpler substances. A decomposition reaction is a chemical change in which a single compound breaks down into two or more simpler products. Decomposition reactions involve only one reactant and two or more products. The products can be any combination of elements and compounds. It is usually difficult to predict the products of decomposition reactions. However, when a simple binary compound such as HgO breaks down, you know that the products must be the constituent elements Hg and O2. Most decomposition reactions require energy in the form of heat, light, or electricity.
Emily Hogan with single replacement reaction. Single replacement reaction. If you drop a small piece of potassium into a beaker of water, it creates a vigorous reaction. The equation that represents this reaction is 2 potassium plus 2 water to 2 potassium hydroxide plus hydrogen. Another similar reaction is when you drop a piece of zinc into a solution of copper nitrate. This reaction occurs zinc plus copper nitrate to copper plus zinc nitrate. These equations are examples of a single replacement reaction. Single replacement reactions continued. A single replacement reaction is a chemical change in which one element replaces a second element in a compound. These reactions are identifiable by noting that both the reactants and the products are made up of an element and a compound. The reacting element in the equations mentioned is zinc replacing copper in the reactant compound, copper nitrate. The products are the element copper and the compound zinc nitrate.
A double displacement reaction is when the anions and cations of two different molecules switch places, forming two entirely different compounds. These reactions are in the general form AB plus CD yields AD plus CB. One example of a double displacement reaction is the reaction of lead-2 nitrate, PbNO3, 2, with potassium iodide to form lead-2 iodine and potassium nitrate. To solve a double displacement equation, you start off by writing the skeleton equation. To solve a double displacement equation, you set up a T-chart and count how many elements are on each side. By doing this, you can figure out how many each side needs more of, and then you can get the final balanced equation.
My name's Kevin Crowley, and I will be talking to you about how to write double replacement reaction equations and combustion reaction equations. And a combustion reaction is a chemical change in which an element or a compound reacts with oxygen, and that often produces energy in forms of heat and light. Writing equations for double replacement reactions. So first write the skeleton equation, which is potassium carbonate plus barium chloride yields potassium chloride plus barium carbonate. And then you make your T-chart, which is on the bottom left, and it shows that there's 2 potassiums on the left, 1 on the right, 1 carbonate on each side, 2 chlorines on the left, 1 on the right, and then 1 barium on each side. And then if you put a 2 in front of potassium chloride, then the equations become balanced because there's an equal number of each elements on both sides. Writing equations for combustion reactions. First, you start with the skeleton equation, which is ethanol plus oxygen yields carbon dioxide plus water. Then you make your T-chart, which has 2 carbons on the left and 1 on the right. 6 hydrogens on the left and 2 on the right, 3 oxygens on the left and 3 oxygens on the right. And then if you balance, try to get an equal number of each element on both sides of the equation. Your final answer is down below, right there, as you can see in the picture, that all you have to do is put a 3 in front of the oxygen on the left side, a 2 in front of the carbon dioxide on the right, and then a 3 in front of water on the right. And that is how you write equations for double replacement reactions and combustion reactions.
In this video, we learned about combination reactions from Kathleen, decomposition reactions from Taylor, single replacement reactions from Emily, double replacement actions from Mike, and combustion reactions from Kevin. Thanks for watching!